We've been looking at using partial fractions to break up these expressions so we can integrate them. And I mentioned previously that that process only works if the expression is already a proper fraction. So I wanted to remind us what that means and what to do if it's not proper. So remember, a rational expression is just a polynomial over a polynomial. I've just named them n and d for numerator and denominator. And much like regular fractions, the thing on bottom needs to be bigger. Well, for polynomials, that's degree. So to be a proper rational expression, the degree on top needs to be less than the degree on bottom. If that's not the case, remember, we can do what's called polynomial long division to get it into a proper fraction. So I wanted to take a second to look at a situation like that. So say we started with the integral x to the fourth over x squared minus 1. Now, the bottom factors, right, x plus 1, x minus 1. So immediately we think we can do partial fractions on that. But the degree is 4 on top, which is bigger than the degree on bottom. So we need to reduce this by division. So remember, we write out something that looks a lot like long division for numbers. And instead of each place being a place value, it's a degree value. So we want to have a column for every degree, even though that expression only has a fourth degree term. So we usually put in zeros as placeholders. And then just like with numbers, we really focus on the lead terms there and kind of work our way through. So the first time through, I'm just trying to divide x squared into x to the fourth. So x squared. So that goes in there, x squared. And then just like with numbers, you then multiply and find your remainder. So that's x to the fourth minus x squared. And then subtract. And you're going to have, and be careful, you know, unlike with numbers, you can have negatives inside there. So that's minus a minus. So that's x squared. And I'm going to go ahead and bring down the next two terms because this expression goes from second to 0 degrees. So now I'm trying to divide x squared into x squared. That's easy enough. X squared divided by x squared is 1. So that goes in there once. Now multiply. And subtract to get your remainder. Now, you know you're done once you've got something proper, right? At this point, I'm trying to divide x squared minus 1 into 1. That's 0 degree, that's second degree. So what I have left is my proper remainder. So at this point, our integral, when we divided, we got x squared plus 1. And then plus the leftover part, which was us trying to divide x squared minus 1 into 1. And now this stuff is just a polynomial, so we're just doing power rule on that. And then the partial fractions is just on that one little piece there, and that's now proper, right? So be careful. If you try and use what we've been doing on this before making it proper, you're going to run into some contradictions. You'll get that A or B should be 0, but simultaneously should be 1. And so that should be a tip-off that you forgot to do this. So if it's not a proper fraction to start, your first step is going to be do that polynomial long division from algebra, and then you should have something that's proper, and then you can do your partial fraction.